In nuclear physics, nuclear fusion is a nuclear reaction in which two or more atom nuclei collide at a very high speed and join to form a new type of atomic nucleus. During this process, matter is not conserved because some of the matter of the fusing nuclei is converted to photons. Fusion is the process that powers active or main sequence stars. The fusion of two nuclei with lower masses than iron, which along with nickel has the largest binding energy per nucleon, generally releases energy, while the fusion of nuclei heavier than iron absorbs energy. The opposite is true for the reverse process, nuclear fission. Our world is made of elements and combination of elements called compounds. An element is a pure substance made of atoms that are all of the same type. At present, 116 elements are known, and only about 90 of these occur naturally. During the formation of the universe some 14 billion years ago in the so-called Big Bang, only the lightest elements were formed, hydrogen and helium, along with trace amounts of lithium and beryllium. As the cloud of cosmic dust and gases from the Big Bang cooled, stars formed, and these then grouped together to form galaxies. The other 86 elements found in nature were created in nuclear reactions in these stars and in the huge stellar explosion known as supernovae.
Firstly, what are the advantages of fusion power? The world needs new, cleaner ways to supply our increasing energy demand as concerns grow over climate change and declining supplies of fossil fuels. Power stations using fusion would have a number of advantages. No carbon emissions, the only byproducts of fusion reactions are small amounts of helium. Its energy efficiency is 1 kilogram of fusion fuel can provide the same amount of energy as 10 million kilograms of fossil fuel. No long-lived radioactive waste because the only plant components become radioactive. These will be safe to recycle and dispose of conventionally within 100 years. It's very safe due to the small amounts of fuel used in fusion. It means a large-scale nuclear accident is not possible. So what's the problem? If you put a normal neutral gas, such as oxygen, in a container, you can increase both pressure and temperature by compressing it. Plasma, on the other hand, consists of charged particles at sufficiently high temperatures, and as a result, would melt the container walls. Also, without maintaining conditions carefully, the electrons tend to reunite with protons, creating a neutral hydrogen gas that's useless for fusion. Stars are born in nebulae. Huge clouds of dust and gas collapse under gravitational forces, forming protostars. These young stars undergo further collapse, forming main sequence stars. Stars expand as they grow old. As the core runs out of hydrogen and then helium, the core contracts and the outer layers expand, cool, and become less bright. This is a red giant or red supergiant, depending on the initial mass of the star. It will eventually collapse and explode. Its fate is determined by the original mass of the star. It will either become a black dwarf, neutron star, or black hole.